The UCLA Physics and Astronomy is unique because of the setting of the UCLA campus, which is a very well-regarded public institution, top-ranked among many rankings internationally. We draw very good students. We're the most applied to institution within the U.S. for undergraduate education. We have a large number of faculty, around 60 faculty within the program that can take on students looking to do research in those areas. The graduate program is about 200 students at a time. Undergraduate about 500, so it's one of the larger programs within the U.S.
Because we are such a large department, we have professors working in the theoretical and experimental aspects of a wide range of topics. Particle physics, nuclear physics, plasma physics, condensed matter physics, biophysics, accelerator physics, and astrophysics.
At UCLA, physics graduate students have access to phenomenal research opportunities in both experiment, modeling, and theory. There are also teaching opportunities where students can TA either labs or curriculum, and students can engage in physics education research that is optimizing undergraduate education.
The faculty in UCLA Physics and Astronomy are distinguished. They're intellectual leaders in their fields of scientific research. They've been recognized with a number of awards. For example, membership in the National Academy, awarding of special grants such as the MacArthur Fellowship.
In the Atomic, Molecular, and Optical Physics group here at UCLA, we're really about producing quantum matter and learning to control it. So in AMO, the techniques we're developing, we get to turn them around and ask, real fundamental physics questions like, is this model of dark energy correct? Or, are the fundamental constants of nature varying? Those same techniques can be used to build things to look for, oil fields or to make better GPS.
So the goal of my research is to build a theoretical framework within which we can understand how natural immunity works and when it fails. And then we can try to manipulate it, the selection, to overcome the limitations, meaning we can help design better vaccines. So one essential part of this is to make predictions that can be tested by experiment. In UCLA, we have a great medical school, so we can find our colleagues to test the predictions and help develop better vaccines.
My immediate area of research is in particle physics, where we use accelerators to look for new forces and new particles. The nuclear physics group in our department works at the relativistic heavy ion collider in Brookhaven, New York. They've built a lot of detectors and they study the conditions of the universe 1 microsecond after the Big Bang. The custom electronics boards that we built for the Large Hadron Collider looks at 40 million events per second for determining the very small number that can be written to disk for later analysis. Having the highest energy accelerator allows us to study the forces of nature at a distance scale smaller than has ever been probed before.
My research mostly focuses on turbulence in plasmas, and there's two motivations for this. The one that's probably easiest to explain is magnetic confinement fusion energy, where we're trying to do what the sun does in the laboratory on Earth, confine a very hot plasma for long enough for fusion reactions to occur. And we use magnetic fields to do that confinement. My research studies how the plasma tries to get out of that magnetic cage via turbulent processes.
I think graduate students really are well respected here, and the voices of graduate students are heard. And graduate students currently are looking to find how to optimize undergraduate experience and create an environment where undergraduate voices are heard as well. Also, UCLA is the California site for the APS Conference for Undergraduate Women in Physics. And we are very excited about this and preparing it, and we're going to be inviting all California women physics majors to apply.
One of the things I really love about the Department of Physics and Astronomy is how large we are and how collaborative we are. On at least 3 occasions, I've had graduate students who came across problems that were not normally encountered by particle physicists, but there were other faculty here in the department that were able to help them.
It's the campus setting that we benefit from, so very well-regarded departments outside of physics, including our own, things mathematics, chemistry, engineering. There's a number of institutes we can collaborate with, so it's a very rich and rewarding environment to do research in.